Good morning, good afternoon, good evening, everyone. Welcome to the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, March 19th, 2018. And today we have Gachua Wambegwith with us in this session of Exploring Plasma Science, Part 6. So good morning, Gachua. Glad to have you here.
Thank you very much, Flint, and good morning, good day to everyone, wherever you are. I'll go ahead and share screen, and then we'll take it from there. Today, we continue with the definitions of terms. And as a way of introduction, these are the things that we cover today. The basic study is definitions of basic plasma science terms. It's not just the definition. When we discuss these definitions, we understand even more. Some of these terms, as you all know, are new in science. So it's good to discuss them so that when they are used in the text, we understand them better. So we'll start with a review of the plasma science terms that we covered last time. And then, as a way of discussion, we'll first try to define the terms in our own words, and then look at the actual definitions of those terms as presented in the books. But the books are written by Mr. Keshe. And then we'll have questions and discussion session. These terms that we define are mostly based on Book 2 and Book 3. And these are the three books that Mr. Keshe has released: The Universal Order of Creation of Matters, The Structure of the Light, and The Origin of the Universe. So these terms are defined mostly in the 2 and 3 books, Book 2 and Book 3. So what we covered last time were 8 of those terms, and today, if time allows, we plan to cover 9 more terms. And here are the terms that we defined last time: MAFs, magnetic, magraphs, PMF, plasmastic magnetic fields, principal matter, principal magnetic fields, principal star, and transition energy. And today, these are the terms that we will define: transition matter, transition magnetic fields or transition MAFs, Gans, inertia, gravity, nano, field interaction, initial plasma, which is neutron, and neutron decay. So in your own words, please define the following terms: transition matter, transition MAFs, and Gans. Please feel free to unmute and respond. Thank you. Anyone can start.
And as a reminder, please raise your hand and I can allow you to speak in Zoom here, or if you have a statement, you can be in Facebook or YouTube or live stream. I can announce it for you.
Perhaps, Flint, you might want to start so that others you bring others to speed, up to speed. Some of them hesitate. This is not a test, so is you can't be wrong. Just try to define them.
Well, out of the three states of matter that are defined, there's the echo here. Is it your speakers there, Gatwa?
Is that maybe? So should I turn it off and
Well, if
test?
either you mute or turn down your speakers. Okay. Yeah, that's better. So, in the three states of matter of principal matter, transmission matter, transition matter, and regular matter. Transition matter is the in-between one, where it's what we would call, our normal scientists would call that dark matter in today's definitions. But transitions matter is a much better statement for it because it's a state of energy flux from one state to another where you have a lot of, well, transition or energy fluctuation. So it's a in-between state, for as far as I can understand it or explain it, from principal matter down to regular standard, what we would see as touchable, feelable matter in our senses. And as an example that you could probably think of it as, it would be the magnetic gravitational fields around our Earth are the beginnings of the transitional matter for this planet, as far as it, turning this energy from the sun and from the universe interacting with the fields of our planet, and then interacts and creates different matters here in our realm. So is that
Thank you very much.
understandable?
How about the rest? Yeah, let me actually annotate to make it clear what you just explained. When we think of the fundamental plasma, we think of these were known previously as antimatter 1, antimatter.
Or what Mr. Keshe relabels and renames as principal matter.
That's correct. Principal, now known as principal matter in plasma science.
Because it's a collection of the magnetic fields that are the source of all that is.
That's correct. So this is known as transition matter in plasma science, previously known as dark matter. And then this is the matter itself. So what we are defining here is transition matter. This part, that part. So that's what is known as transition matter. It's in transit from principle to matter. If you think of a ring, magnetic ring, what do you call this? Yes, magnet, a magnet, that is a ring. The principal matter would be right in the center where there is a void. It looks empty, but because these are fields, and fields are both gravitational and magnetical, and then the transition would be this part between the principal matter and what you actually see. So this would be the strongest, the principal, in terms of the field strength. And then as it transits towards matter, the ring, this would be the second strongest, and the weakest. So as gravitational magnetic fields weaken, they become matter. So what we see is the weakest of the gravitational magnetic fields. So what would be transition mass? Mass start for magnetic fields. So those are the magnetic fields in transition here. How about Gans? Anyone? Or are there any questions about what I just annotated here? Silence.
Yes, anybody want to take a stab at Gans?
How it goes, Gans. I think it's the easiest one of all because it's the one we work with, really.
Okay, go ahead, John.
Gas in a nano state in a nano state, what it solid nano solid state. This material is in a matter state, but it is not. It hasn't got the characteristics of a matter state because it's in a gas state, but it manifests itself as a solid state. But as being solid, it's not united one molecule with the other because it behaves like a gas. And it's a nano state because it's in a molecular or nuclear state. They're all separated. They're in an equilibrium between the magnetic and gravitational fields of each atom or molecule.
Okay, thank you very much, John. And this happens to be one of the new terms, very new in plasma science.
Yeah.
Prior to plasma science, guns were not known. So how do
And-
we get
yeah.
guns?
And the main characteristic is its pure energy, practically. It concentrates a hell of an amount of energy, each molecule or atom.
Okay, so how do we get guns?
Well, we do this in what we call this, the containers, the Gans container, was it? In the translation they call it reactors, but I think it's misleading the people. We have a container where we have salt water or seawater. We have a zinc plate, the first experiments we do with, and a copper plate where we process it or modify it by heat or caustic soda.
We are making.
What we do with this plate, this copper plate, we create or let it manifest itself with layers of 40,000 or 50,000 layers of free atoms on its surface, and these surfaces are a speedway for plasma energy.
In simple way, John.
Pardon?
In simple way, we are making magnets for pulling the guns.
Yeah, exactly. Well, these will be the highways where we sort of take the carbon from the air, put it into the water, bring it into the water, and it oxidizes with oxygen in the water. And there we have CO2, what we normally call CO2, which is well, I'm trying to translate the different terms because I'm thinking of it in Spanish. What we normally see in a soda water, which is CO2 gas, which makes carbonic acid. Here we see it in a Gans state, which is in a solid state but in a gas configuration, and it's in a white state. We see it in as a white powder dissolved in the water.
Thank you very much, John. That's pretty good. This actually has brought about some very good points that we can discuss further by way of annotation. So I'm going to do exactly that. So what John and Jalal have just been talking about is how we get CO2 from the atmosphere in ways that we can use it and in ways that it's a solid. So Gans gases in nano-solid. So how do we do that? John just explained that we use a nano-coated copper. This could be either a plate, nano-coated copper plate, or coil. And then on the other side, we have a zinc plate. And then we connect both using a copper wire, for example. We connect those. And then some also use LED here, connect them and reduce the current that flows. Then you put this in a salt water solution. And this salt water solution is at the recommended salt water solution is about 5%, 3.5 to 6, 3.5 to 3.5 to around 7.5, let's say, percent of salt in the water. So if you use 5%, for example, that's very good. The oceans are at about 3.5% salt water. So how to do this? If you use the way I do it is if I add in water 20 cups, if I measure 20 cups of water, for example, or 20 bottles or 20 liters, then I use half a liter of salt. Have a, let's say it's a container that holds a liter, or that's why it's best to use cups instead of liters. So if I fill 20 cups of water, I use half a cup of salt. So it's at 5% by volume. So that makes 5% by volume salt to water. And that's how I mix my solution. Okay, so we have already talked about nano-coating. Copper is nano-coated. There is a reason to nano-coat this copper. And there is a process of nano-coating. And that's what I will explain now. You take a container, plastic container, hard plastic container. It needs to be hard because you're going to use caustic soda which bonds. So you want a container that is hard enough, that's good enough to contain the heat that will be generated to take it. So here you start with add caustic soda to this plastic container. So that it comes to the bottom, it's like a salt or ash. So we put it to cover the bottom of this container. And then on top of that, put a mesh wire here, mesh wire, so that the mesh wire is where you put the nanomaterials that you seek to nanocoat. This could be either plates, a plate.
Joshua,
Yes?
we should add that we recommend the galvanized iron wire because the zinc in the galvanized helps this process also.
Okay, thank you. Thank you very much. That's a good point. So this could be either a plate, copper plate, or copper coil. And these coils, anyone can make. You just take a wire and coil it around like a piece of wood or something. You coil it like that. And then you can use it. You can either use the plate or the coil. So now when you put it above the mesh wire, chicken wire is usually galvanized. Chicken wire mesh is galvanized, and galvanized means it's coated with zinc. So it's iron coated with zinc. And both of those materials are important. That's why John mentioned that, which is good. So now you need hot water to start this process of nano-coating, and a lid. Here you have to cover this top, because this is going to, once you add caustic soda, with caustic soda is NaOH, which stands for sodium hydroxide. So you add the hot water now into that solution, making sure that this is, you open a bit at one corner. That's where you add the liquid, the hot water, and then cover it immediately and place a load on top to keep it in place. Because what's happening here, there is a reaction and it burns very hot, very, very hot. Now, what does that burning do?
May we add some safety features? Use gloves and eye protection and face protection if you got a better protection to cover your face for if you do splash or have the vapors jumping towards you.
Thank you very much, John. So make sure to cover your eyes and nose. You don't want to breathe these fumes. And also your eyes, because it's caustic, it burns. It could burn your eyes, so you don't want that burning. You want to be very careful when you do this. So you leave this for at least 48 hours. At least 48 hours. But the more you leave it in there, the better. So it could be longer, 48 or longer. It could be days, it could be weeks. It works well. Then there is a second process, which is nano layering. Now, what happens here in this process, the copper plate or copper coil, the copper atoms actually pop like popcorn and lay themselves above the wire, the copper plate or the copper material itself, the non-nano-coated. And these are tiny layers in nanoscale, and they could be up to from 20 to 50,000 layers on top of the wire. And it's very interesting what these do, because first, this material now, nano-coated material, becomes both superconductor and super insulator. So super insulator is like it creates a boundary here on top that does not allow things to come from this side up. So it insulates that. But here you kind of create a superhighway where you have, because these atoms are now independent. They are not attached. They are independent. So there is movement here, and they accommodate each other by way of gravitational magnetic fields, magravs, positioning. That is to say, if one pops right now and feels that it wants to be here, the others accommodate it by moving a little bit, just like you move magnets. Magnet, when you move it, the other magnets may move, yeah? So the same thing happens here. One pops up, takes a space, and the others move to accommodate it. So you have 20 to 50,000 layers, and you create a plasma now, and you create also pockets where plasma can be stored, and energy. You can store energy, and you can store information. But for the purposes of making guns, that material that is now a superconductor and super insulator also becomes part of the magnet that attracts carbon from the environment. And the carbon comes in and mixes with the oxygen that is in the water solution. And then now you have CO2 in nanosolid. It becomes solid. Are there any questions now? The second, I was going to explain the second process. The nano-coating does not end here after 48 hours or longer. Now you repeat the same process here. You repeat, except now the copper materials are above the liquid. So when you add hot water, what happens is you create steam, and this very hot steam, once the layers, now the layers start growing. They popped in this process, the first process, but now they grow up to 20,000, 20 to 50,000 on top of the wire. That's what I explained here. So that's called nano layering. And now, in order for them, because every plasma has an entry and an exit, what you want to do, like a ring magnet, for example, has an exit and an entry. And you can also think of those as the positive and negative in terms of how these materials have arranged themselves in terms of magnetic fields. You want them pointed towards one direction, or the plus, or the positives in one direction, so that this becomes a very smooth superhighway where you can store a lot of information and energy. That's basically what John and Jalal were talking about. And Jalal mentioned that we just simply create a magnet to attract carbon. And that is also true. You can also look at Gans in nanosolid, the Gans that you collect in this setup. You can look at them as small suns. Each tiny dot, each tiny atom of those gases in nanosolid that you actually collect here are like small suns. Small suns. It's like you have just brought a lot of suns. You made a lot of suns. Because they have power, they have, each of them have the principle, like the plasma that I explained earlier, as a principal matter, transition matter, and matter itself, what you see. Okay, not what you see, but the fields. What you see is, yes, some of it you see. Okay, that's what...
I would add 3 details, Gatwa.
Okay.
When we do the vapors of the caustic soda, we normally hang the plates or the wires, those springs made out of copper wire, up, hang them from the top of the container, so they only receive the vapor of this caustic soda. And
yes,
touch those plates as less as possible. Just grab them in a very soft way from the extremes. And we polarize, or polarize the plates or the wires with a multitester in the alternate current measuring device with a 200 millivolt range. That'll create a polarization on those plates.
That's correct, John, and thank you very much. What I do is I don't necessarily hang my plates, but you could also call it hanging. What I do is like I have the mesh wire that stands with the legs, so it's above the water, and then here it's also flat on top. So it is true that the materials, the nanomaterials will be hanging because the liquid will be below. So that's one way of explaining it.
Yes, in this case then, the first process, which you do the wet processing, would be in a very low down mesh, and the second process would be with a high mesh.
That's correct. And the low mesh, you make sure the first time they are actually they are submerged in the liquid. In the second process, layering process, they are above the liquid. So this is only steam layering. Thank you.
And
Thank you, John.
also try that if you're using the copper plates, may they touch the mesh in 2 or 3 points, bend them a bit, so they will only touch in certain places and not in many places.
Could you repeat that, please, again?
Yes, when you put the high mesh and the plates on the mesh, may bend the extremes or the points of the plate a bit, so they will only touch in 2 or 3 points. May they avoid touching all the mesh, because that'll produce places where the nano layer won't be continuous. There are small details which help the process to be in a more of a perfect way.
Yes, thank you very much. Any other comments or questions?
Yes, the very all-important last step is to rinse your plates with distilled water so you don't have caustic on them when you use them in the Gans making process.
Yes, and that's a very important point. Clint, thank you very much. Do you have a way that you use to thoroughly rinse?
Well, what's been taught is using 3 containers of distilled water, and you do a 1, 2, 3 step process to make sure that nothing resides in the nano layers. So the first bucket would be, you dip it in there, and you're just holding your wires by the ends or the plates by the edges, and kind of swishing them around.
And making sure that you don't break the layers that you just created.
Yeah, correct.
They're very sensitive, so you can't just hold them with your fingers. The moment you put pressure there, you kind of compact them. So I usually leave a small piece of hanging copper wire at the end, so that I can hold that when I'm dealing with the nano materials. Also, I use it to when I connect these wires, connect the plate or the coil with another, I leave something above. So if, for example, these were a coil, then I have something on top where I can insert the wire material that I used to connect. So that's also very important. And I have noticed that if you leave a lot of the nano-coated material, copper, in this case, above the saltwater solution, you are likely to see a different color of Gans. Like if this wears off the nano layers, then they start producing a greenish material, Gans, and that will be copper oxide Gans. So you want to pay particular attention to that. Make sure that when you're making CO2, you don't mix it with copper oxide Gans. When it starts looking greenish, then you know you're mixing. And that means you use different nano coated copper, or I usually actually do nano coating again, but Mr. Keshe says that you use the first one all the time. But I've noticed that the little that is exposed above the liquid, the salt solution, always wears out. It's oxidized, I guess, and what happens is the layers wear off and I start seeing some green gums. So I changed the plate. Has any one of you noticed that in your guns making processes? Anyone? John, have you noticed any of that?
Bonnie had her hand up, so yes, Bonnie.
Yes, me. I noticed blue Gans, and I wondered how it kept turning blue when I was making CO2. It would just happen quickly overnight. You know, I'd be watching it, and then all of a sudden, the next day, it would be this pretty baby blue, but I knew it was like, oh, nuts, it had copper in it.
I haven't seen blue, I have seen greenish, but I think it's the same thing. Maybe your copper had some, it's not always that you get copper that is 100% copper. So you get plates that are maybe 99 or less copper. So they have different, they have additional materials usually. So maybe the blue comes from those additional materials. That's all I can say now because I don't know why. I haven't seen blue in my guns. I have seen greenish.
Yeah, we could also call it
Okay.
turquoise green or turquoise blue because copper oxide has a tone which turns to sort of a light blue or a light turquoise green. All depends, as you say, the additional or the isotope of copper you got on your plate.
Okay, thank you very much. In this slide, we have explained a lot of processes that take quite some time to master. So excuse us for being so brief, but I wanted a discussion so that we understand more.
Andreas, you had a question?
Good morning, Andreas here. No, I don't have a question. I just want to add to the turquoise or blue. I think the blue is turquoise, which the woman told before. I make now, I don't know, 20 CO2 productions because when it's finished, I give the first salt water out of everything out and then I pull all together or give all together. So I have not the effort of washing everyone single. And what I want to say is that every coil is coated at the same way. And there are two where the turquoise color is, and I cannot find the thing where I say why these ones are turquoise or not turquoise. And so it brought me to the idea that I try Gans production where the coil is outside of the plastic box, and it works too very good. And I like it because the coil does not gets worse, and I want to do it this way more because I have cleaner guns, and I want to ask if somebody knows if that is a different guns. You know what I mean?
Could you repeat that? I didn't really quite get it.
I make Gans where only the zinc plate is in the plastic box in the salt water, and where the coil is outside of the box. And the Gans production is the same. And when I have, for example, when I make CO2 Gans, I have the nano coil in it. Sometimes it comes to that the color gets a little bit turquoise. And so with that the coil is outside of the box, the color don't get turquoise because the nano coating or the copper under it is not interacting with the salt water or with the and I wanted to ask, is it a different guns if you have the nano-coated copper coil outside of the plastic box, so not in the salt water, because it works too?
It's not as different as such, but it may be cleaner.
Yeah, it's cleaner if we make it that way when the coil is outside of the box.
Yes, but sometimes it's not as easy. I have tried that. I have done it, and it may take a long time to get the guns. So if people have time, or if they can try, and probably they'll get better results than I did. But from my own experience, I found it to be a bit slower. The process to be slower. So you get very
Okay.
little guns over time, over a long period of time. But if I make it with the plates inside the salty water, I get guns within an hour. I have quite some. So it depends, and there is nothing wrong in experimenting. And Mr. Keshe says that we can't go wrong with plasma. So try, experiment, and then share with us. Thank you very much.
Thank you too.
Sure.
Can I add something? Gatwa?
Yeah, sure, Jalal.
The difference between the ganses, if you have turquoise in the plates, that's come from polarization of the plate. If you polarize the plates in the good way, that means you have about 40 to 60,000 layer in good condition, not in in one-way polarization for 6 or 7 or 8 times polarization in the first day and the second day of steaming. You will not have this turquoise in the upper of your plates. That I noticed 3 times when I polarized the first plates in a good way, in real good way. I didn't find any turquoise color in the plates. When I done it second time with 2 times polarization, I noticed all the time I have this greenish turquoise color in the plates. Whatever I do.
That's a very good point, Jalal, because
Yeah.
now if it's the layering process, this is the second stage of nano coating. The first one is where you have the nanomaterials, copper materials inside submerged under the what we call it caustic soda solution. So Jalal is saying that if you do the proper layering, which means using multimeter to actually polarize the atoms, the copper atoms now, so that you have positives facing one side and the negatives facing another. In other words, you have an entry and exit of this plasma space that you create, the plasma material and the nanomaterial and the space in between them. Then the layers form better so that you never have the what I call green coloring, green or turquoise of the copper materials that is exposed to
Yeah.
the air
Yeah.
above salt water solution.
Yeah,
And that's very
because this is
that's a
the
very good point.
interaction. Because this is the interaction between the inner copper and the outer layer of the nano coating. And there is
Yeah.
one more polarization. You don't need to use this voltmeter or what you call it voltmeter. You can use the plasma battery, or this is the best way, Mr. Cash said, in layering the nano-coated layering polarization. This is the best ever way that you use the plasma in that.
Do you know how that is used? Can you can you
I
annotate
cannot,
that?
I cannot annotate, but let me see. Wait a minute. Yeah, I will do that. You have here your box. Let me go there. You have here the mash and here the mash. If
We don't
you
see here.
now it's coming. Wait a minute. If
Okay.
you put here a plasma battery with it's coming out. If you put here plasma outside the container, minus and plus, you will have always plasma condition to layering the process, and it will be the best way you are layering your nano layers.
And those that will be outside the plastic
Yes,
container?
outside the plastic. This process you make it after the first day of steaming, and you put that, and all the way, if you put it 2 3 days, 4 days, 5 days, 1 week, you have always pulling of what you calling the perfect layering in plasma state.
Oh, that's very good.
And
Thank you very much.
it is very, very powerful. If you are speaking about let's say actually 20,000 layer what function in your normal copper plate, you will have about 60,000 layer is working absolute as a one, and this is the difference.
Then you never get the turquoise or green material.
Absolutely not. And your nano coating will stay black always. It will not dissolve anything.
How does this the one you just talked about, plasma battery, is it outside completely, not connected to the plastic
It's
material?
no, it's connected to the mesh. You
Or
you
how
you
is it?
you take one wire out from the container and one wire from the down mesh. So you have two wires outside, and you connect your battery outside. If you can make a hole in the body, or you can take it from above. You make a hole here, and you put your battery outside. As you know, as the what do you call it? Like Alex Beat. This is advanced method. That mean after when you are beginner, after you make all these kinds of layering and nano coating, and you will have this ganses, and then you go to step further. When you collect the ganses, you try to make the battery of plasma, and you make the capacitor. Just make a small capacitor, and the wiring with minus and plus, and connect it to the plates. Not the actual plates, the mash, one mash down and one mash up. So you will have connection between them. Make it in good condition that all your wires or your plates is connected down and above, and you will have very plasmatic condition, real good condition.
Thank you very much. Thank you very much, Jalal.
You're welcome.
Has anyone else done that or know something about it? Do you have a reference, Jalal, where we can actually see that teaching?
This is in the private teaching, and that's why always I'm saying to the guys, please join the private teaching. It's only €100 for 1 year, but you will learn so much. All the science is there.
Perfect. Thank you very much indeed. Any other points, any other perspectives, any other explanations or any response? Clint, do you see some questions coming our way?
No, I don't. It's pretty quiet out there in the broadcast channels.
I noticed that Q&A may have a couple of questions.
Ah, thank you.
Sure.
Mr. Constantine says nano-coating in plastic is different than nano-coating in glass. And Nicholas would like to know if you use a plasma battery. So,
well, at least Jalan named the plasma battery. Nano-coating in a plastic container is desired, is recommended, because you have all the plastic material has CH bond, which is good for our process of making guns. So for nano-coating, it's recommended that you do it in plastic containers, not glass.
Question about the plasma battery. Positive to the mesh and negative to the mesh above. I don't understand what you mean.
I think what Jalal meant is that when you are doing the process of, let me annotate again above, and thank you very much for your question, Nicholas. Seem to know everybody's by their voices. So you know what we said about nano-coating, you have the mesh down here, and in the second process of nano-layering, you have a mesh on legs. So it's above the liquid, and this is what Jalal refers to as the mesh above. And the one that is here is what he refers to as a mesh below. So if you have your plasma battery outside here with a positive side and a negative side, then you connect either this to below one and this to the top mesh. It doesn't matter which one. You can do the other way around with the positive at the bottom and the negative at the top. Provided you do it for both mesh wires, that works. And the easiest way to do this is to have one, for me, I'll make sure that this mesh, one of them protrudes right at the beginning, outside of the box, and the other one here. So you have a continuous, you can just attach this when you get to the second layering. And make sure that liquid doesn't come from those holes. So they don't necessarily have to come straight through they can come from top. You can get them from top, and the other one here. That's easier, that's better. Because if you drill a hole here at the bottom, then you are likely to lose that caustic solution, caustic water solution, which then would be not good, and it could burn your skin. So do it from the top, but connect it to the below mesh, one, and the other one to the top mesh.
So the below mesh is in the caustic, and the upper one is not.
The other one, you know, when you do nano layering, the nano materials that already went through the first process of the mesh, submerged in the caustic water solution. The second one is not submerged; it's above, but within the same container. So you can create a stand of mesh wire. I usually do it this way. I bend them over at the extreme so that they stand inside the container. You see what I mean? So the mesh stands right there. It's on top here, but it goes all the way to the bottom, so that you would have it this way. The first one is submerged. The second one is not submerged. It's above the liquid, and then you have a cover in all cases. And so you can have this wire in outside, connect it outside and connect the top one, the below one here also. Somehow be creative so that you can attach the plasma battery, positive and negative, or the other way around. That's what I understood Jalal to say. Is that, did you get it? Or do you still have any other questions, Nicholas? Does that make sense?
Well, I get it. I've just never done it that way. I have a bottom mesh, and I was hanging my plates from a copper wire on top for the steam process. So,
Oh, okay. I see what you're saying. I always use another mesh above that is now suspended. It's above the liquid. And it's easier to place the materials because maybe you don't have a lot at the same time, but I find it easier to just have a mesh above that is not submerged in the liquid, so that instead of hanging them vertically, I just place them on top vertically.
you still do them vertically?
I mean horizontally. So if they're hanging, you have to attach them somehow, yeah?
Yeah.
But if you have a mesh, you just place them on the mesh. You don't have to have an attachment.
You're only doing one at a time?
Oh, okay. I don't do one at a time. I always do more than one. But I see what you mean. So you'd find a way of connecting whatever you used to hang it with. Then you connect that, but that would be directly connecting it to the material, not to the mesh. And try it. It may work even better.
Very good. Thank you.
Sure. You know, we have to keep trying. Everything we think about, we try. And we may have better results. Any other comments? So are we now satisfied with the definitions of transition matter, transition, magnetic fields, and Gans?
There were, excuse me while I get my mic going there in live stream. There was a couple of questions in live stream from Stephen. I'm not sure if it's quite appropriate, but if you consider as part of a couple of our definitions, first two definitions, he asks, how do you create a field with a dynamic reactor? And can you create a field in a tubing with a flow of Gans? Create a field in like plastic tubing with a flow of Gans.
Well, my immediate response would be we are dealing with definitions now. I mean, there is a lot to learn about rotating cores, dynamic cores, but that's not part of the definition. So I think I want to stick to definitions for now.
I thought you might say that. Thank you.
Oh, sure, you're welcome. We don't want to explain everything at the same time because then it may get very confusing.
Yes, good. So just remind people to keep their questions to the topic.
Thank you very much. Any other comments or questions that are related to this topic?
I don't see any others in Facebook or YouTube.
Okay, in that case, we will just proceed with the next 3 terms. But before we do that, we will now go to the book definition. What we did right now is, in our own words, we try to explain or to define those terms the way we understood them. Now, what does the book say about those terms? Transition matter. This, let me also annotate here as I explain. This is, you see here, it's antimatter. It may not look very clear. That this is the way we always, science explained matter. This was an antimatter. And that's what Mr. Keshe now defines as the principal matter. Principal, the main, and that's is in plus gravitational magnetic fields. Then the dark matter is what is now known in plasma science as transition matter. And this is the subject of, this is what we are defining here. Transition part of the matter. It's in transit from the principle moving towards the matter itself. If you think of an egg, for example, so you'd have the yolk in the middle, the white of an egg, which would be the transition, and then the shell, which would be the matter itself. Okay, because these are plasmatic, they're fluid or plasmatic. So it's the same thing. It's the same way of looking at plasma. This is the plasma. Also, every plasma has these parts: principal matter, transition matter, and matter itself. So, having known what we are describing here now, or having explained that this is the part that we are describing, transition matter, previously known as dark matter, Mr. Keshe explains that this matter in conventional physics is called the dark matter, as now the real structure of this matter is fully understood, and that is to say, it is when plasmatic magnetic fields are in transition state from the principal matter to tangible matter. Thus, the transition matter is used. Thus, the term transition matter is used, because these matter, magnetic fields, are in transition from the principal to the tangible. Any questions about that or comments?
Well, where can you observe this if it could be observed?
What do you mean? Where could we observe what? The transition matter?
Well, if we can observe matter, but we can't really observe or measure principal matter. Is that correct?
No, we can't, because principal matter is in fields.
So we can actually measure a plasmatic field?
You see, Mr. Keshe explains matters in 2 ways, where he uses capital M matter and small m matter. Now, the capital M matter refers to the plasmatic magnetic fields of this entity. Okay, that is to say, principal, transition, and matter. Okay, those are fundamental matter in fields. But if you look at this part only, this matter part, yeah, this part of the matter with capital M, the small m matter comes from that. Every plasma, remember, every plasma has all these 3: principal, transition, and matter itself. So even within an egg, where you have the yolk, and you can actually see the yolk, that is matter, small m, but it came from this part of matter. The fields of matter create matter. Only the fields of matter create matter. It's not the fields of transition or this. You don't see it in the egg, for example. Okay? Does that make sense, Nicholas?
Well, I understand the diagram. I just
Yes.
didn't realize that we were actually able to measure or observe the plasmatic fields.
Oh.
I thought we could observe the the matter, but I didn't realize that we're actually able to observe the plasmatic fields. We know they're there, but to be able to observe them. And so between the principle, the field, and the tangible matter, we have the transition matter. When you can observe something, you can see it differently. Otherwise, one's having to deal with a theory in a certain way, or an explanation of how something works.
That's correct. So you see, matter with the small m matter, when you can see, solid, liquid, or gas, when it becomes that small m matter, this part is the plasmatic magnetic fields from the, the fundamental, the matter capital, this part. The fields that come out of that create small matter, small m matter, that you can actually see as solid, liquid, or gas. We never see this, but it comes in every plasma, because every plasma, you see, like everything that is plasmatic has all the three. So this part of that plasma, the one that has the principal matter with capital M, the product of those plasmatic magnetic fields and their interactions create the small matter, the small m matter that becomes solid, liquid, or gas. And whatever it becomes, even the solid that comes out of that, will have the same components. In other words, Mr. Keshe explains that even stones have souls. Yeah? So those souls in stones would be the principal matter in the stone. Any questions or comments about that? This is actually very interesting. Once we need to read about this and look at the book's explanation many times. Until you read many times until you really may understand it, because it can be confusing when you see capital M matter and small m matter. The book explains it in ways that are probably easier to understand that I'm doing here.
Well, I appreciate that. It'd be nice to read it. I actually haven't yet, so I need to catch up. But science, my point is that science often realizes that something's at work that you can't see or observe, and so you assign a name to it. That's what I was bringing up. We don't see the soul, but we know that it's there. We experience it maybe, but we actually can't observe it.
That's correct. Even the solid, in the solid one, you don't observe it, but you observe its product. just as you yourself, Nicholas, are the product of yourself. Because we have learned that soul creates physicality. So if we can observe you, we can touch you, we can see you, the same as small m matters elsewhere. Pretty interesting concepts. Because they are new, you have to take time to really understand them. But once you do, then the book becomes easier to understand. So that's why the term is the transition matter. It's in transit from the principle to tangible matter. Any other questions or comments? If not, we go ahead and look at transition magnetic fields. These are magnetic fields which are in strength level between the principal matter magnetic field strength and are in transit from the principal magnetic fields to matter magnetic field strength levels. Any questions? Is that clear?
Clear as crystal.
It's clear as crystal. That's better than mine. Clear as crystal, not as clear as mud.
Yes.
Any other comments?
From Gabrielle in Facebook says, I read about Keshe's researches a couple of years ago. It sounded really strange and mind-blowing at the time, but now I can recognize it will be the future.
Perfect. Congratulations. Or shall we say good morning?
The question is the from Esteban here in Facebook, is the transfer for energy into gas molecules the reason for plasma state?
Say that. Could you read that again, please?
Is the transfer for energy into gas molecules the reason for plasma state?
No, I don't believe so, because even before the transition, the principle is also plasma. Yeah. So what is plasma? It's not the shell. It's magnetic fields in interaction. So if you look at magnetic fields, you start with a ray, a single ray, which is a gravitational magnetic fields with direction. It has direction. So if you have another one here, or when you have another one, because you kind of always do, then it's just like a magnet, yeah? With a magnet, like poles repel and like poles attract, yes? So in this case, if this were the positive and this were the negative, they are unlike poles, so they attract. So they follow one another, and that following now, they take shape. They don't follow in straight format, because we don't see any plasmas that are like rectangles in the sky like the sun or the moon. They're always spherical. So the same with the gravitational magnetic fields when they follow each other, and that following is called interaction. So when they interact, they are playing. Those that interact are those that have similar or equal field strength. So when they start interacting, they create fields. field. In other words, a place where they interact. So there will be fields. For this is the fields created through interaction. And then they will have a magnetosphere where they don't interact beyond, because that's like our atmosphere will be the magnetosphere of the Earth. So in this case, even from right here, magnetic ray, it's already a plasma. The product, even of when they interact, they also create a plasma. So what is plasma? Every plasma is like this. Pass, principle, transition, and matter, magnetic fields. These are the fields. That is to say, and they are products. Even when you see a yolk or an egg or a shell of an egg, each part has those three. So even a ray is itself magnetic, plasmatic. Does that answer the question asked?
So, Gatua, the what we're calling transition matter, that permeates what we call space. That permeates space. Is that true? So that there's no such thing actually as empty space out there, but it is filled with this transition matter.
That's correct. You explained what Nicholas just said is that when you think of Earth and the Sun, for example, both have gravitational magnetic fields. And where they interact, that's where creation begins, at the point of interaction. And if you rub your hands, two of your hands, one and the other, you would see light. And this is the first product of the interaction between the gravitational magnetic fields of the Sun and gravitational magnetic fields of the Earth. In our case, could be of planet Zeus in another case. But where those interact, that line of interaction, light is produced, which becomes the first product of what you'd call friction between these plasmas. These gravitational magnetic fields of the Sun are already plasmatic, and those of the Earth are already plasmatic. So when two plasmas rub against each other, light is created. So you are saying that between the Sun and the Earth is not a void. There is no such thing as a vacuum, for example, because in these spaces, from the Sun to the Earth, it's covered with plasma. And because we can't see an entity, given our amino acid, which is actually what is created in the gaseous environment, what we call the void between the Sun and the Earth, that's when, after the light is created, the interaction continues and nitrogen is created first, then oxygen and carbon, either of those, but a product of nitrogen, both of them. So, and then the remainder of that process is hydrogen, and that forms a complete amino acid, which now is a living entity. Proteins have consciousness. So now this one with its consciousness can multiply itself and become whatever entity it decides to be. But that only comes with a combination where we, on the ground where we are, the Earth If there is a combination of amino acid, this is better written as COHN, C-O-H-N, because we can read it better. It's an easier acronym than NOCH. COHN, we call it. So when COHN combines with iron in the ground, red blood results. So that's how come you have animals and humans. When it comes in contact with the magnesium, then the product is green blood, and green blood, that's the plants, green blood. And this is magnesium. So that's it. So creation begins and continues because where it's created here, it already has consciousness, it can multiply itself, spread itself, and become what it wants, manifest as the entity that it wants to be, given the right condition. Does that answer the question now? Nicholas, then you are saying this.
That's getting there. Of course, even every time you explain it, I guess it's has a newness. Well, let's take a look at the atom. Science says that the atom is, has got a proton, a neutron, electron, and a whole lot of empty space. So even in the atom, then we have these three fields at work.
Exactly. Rocks, stones have souls. You can think of the principal matter as the soul. Any other comments? Questions?
So since everything has a soul in the principal matter, then the soul acts like a field of connectivity because we have a soul and then we also have consciousness and awareness. We can bring to our awareness the connectivity with the totality.
That's very good, Nicholas. That's a very good perspective. Yes, we are connected through our souls to everything. We are one entity.
I was just looking up, it's Rick here. I was just looking up how much of, for example, a hydrogen atom, which is a proton and an electron, right? And I wondered how much of that is empty space. And it turns out that approximately 99.99999999996% empty space.
So what we see is tiny.
Or all space is not empty, it's transitional matter.
Well, that's the thing. It's not empty for sure. But the thing about it is, it's the same with our body because our bodies consists of hydrogen and oxygen, these other atoms and so on. It turns out that 99.9999999% of our body is actually empty space. If you were to look through the atoms at, there's a proton and there's electrons like way out there running around in each of those atoms. And in between is all this space, but that's where the fields are. That's where it's actually the important part is the space, not the atoms in the way.
That's very interesting when you think that humans are themselves universes, We are a microcosm of our universe.
That's right. Yeah, we don't think of it that way because we keep thinking we're solid matter.
Yes, thanks to the de-education program, or is it dumbed down program, so-called education, as has been presented to us prior to plasma science. Very interesting. 99.9999996% of our bodies are empty spaces.
If you look at things that way, it should be pretty easy to make a system that eliminates our tendency to inertia and to have to activate some sort of levitation or flying machine, because we are mostly space to start with. It shouldn't be that difficult when you look at it that way. We're only trying to alter the 0.0000004% of what actually exists inside of us.
In other words, we are already spaceships, only that we didn't know.
Yes, we're already full of space and we didn't even know it.
Yeah, and we've been traveling through space all this time without our remembering. In the form of physicality. But anyway, that's very interesting. Thank you very much, Rick. Any other perspectives or questions? So transition mass or magnetic fields are magnetic fields which are in strength level between the principal matter magnetic field strength and are in transit from principal to tangible, from principal magnetic fields to matter magnetic fields. So these matter magnetic fields are the magnetic fields, magnetic gravitational fields that come from this part of the fundamental matter and can be seen as solid, liquid, and gas. That should be clear. Thank you. So we will continue. Having dealt with transition magnetic fields, we move on to Gans, which is the most amazing. This is what everyone in this class should know, because in one way or another, I suppose you have encountered Gans or made Gans, collected Gans yourselves. So please unmute and let's hear from you, your experiences about Gans. And as explained here, Mr. Keshe explains Gans as a new state of matter, a molecule of a gas. That's where the GA of Gans come from. A molecule of gas which becomes nano of itself and appears as solid state of matter. This is very interesting. Becomes nano of itself. What does that mean?
Well, we know that nano is very, very small. I believe it's what, a billionth of a meter, something like that. So becomes nano, it becomes in a monoatomic or very small size particle.
Thank you very much, Rick. Any other explanations? Nano, in the way nano is defined in conventional physics, it's 1 billionth, 1/billion of a meter. So it's tiny, 1/100000th of a meter. Tiny, 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 whatever it is. But now, 1 billion of those would be a meter. But in the form of Gans, in this case where Gans are concerned, gases in nanosolid, Mr. Keshe also speaks about individuality of those atoms. Individuality. In fact, I believe he emphasizes the individuality part when we talk about nano. Not only individuality of the atoms, but also independence. So they become nano by themselves, and not only that. In addition, they are free. They are free. Individuality. They are independent. And I'm trying to continue here too. I guess I have to clear everything before I proceed. That's the nature of this. Okay, so actually when we go to explain nano, because we have nano, when we explain nano, I'll come back to what I was just saying. But in any case, they are, as Gans, maybe perhaps I should just explain here, and then there is no harm in explaining again, but my mouse is not perfect. I'm getting a few problems here and there. Okay, so becomes nano by themselves, of themselves. So that is a case where we are making CO2 with nano-coated material, copper, nano-copper, and zinc plate. On the other side, we connect those two using copper wire or copper wires with a LED. And then we have salt water solution, NaCl. And then we collect C from the atmosphere, carbon, that mixes, is ionized in the water with additional of oxygen, and then we get CO2. But you think of CO2 in conventional physics or science, when we are in plasma, when you think, you can look at that as COO. And this comes the individuality part. Atoms are now individual and free, independent. Like if this C fuse that with another COO here, this one fuse it's based on its magnetic fields, would rather be here, then it could move to that. And another carbon, because there's no void, another carbon from somewhere else may take its place here. They accommodate each other. So it's free to move from one place to another in this form. So this is what this comes from, individuality and freedom of the atoms within the structure of molecules, as that of CO2, for example. Does that make sense? Is that clear as crystal? Plain?
Yes.
I'm glad.
Okay. Let's go.
Any questions about Gans or anything to say about Gans? This is a powerful material. So I thought stories would be coming from all directions.
Does Gans reduce its strength over time? This is a question from Renee on YouTube. Does Gans reduce its strength over time? For example, if it's used to give energy, is it necessary to reload it from time to time?
That question is loaded in that there are particular cases when you are making a lot of Gans that the material itself, when you are using it to produce liquid plasma, for example, has been seen to be weaker at some point, but in my understanding, it's not weaker. It's the way plasma works, and I'm trying to annotate again. Plasma, Mr. Keshe has explained, works only in one way. If you have one plasma here and another plasma here, the stronger always gives to the weaker. And the weaker also, because of gravitational magnetic fields, always, they are both in the same place, gravitational and magnetic. So even the weaker has something to give. There is no taking without giving, okay? So in that process, what happens? This one gives its field strength to this one. They are trying to create a balance so that they are equal. So now, where it has been seen to be weaker over time is, for example, let's say you have you are using health pads. So you have a human being here, or a human arm, or something. The part that has problems is covered between those pads, and you may have CO2 liquid plasma and CO2 liquid plasma on the other side. And this could be, a finger. It doesn't always have to be the whole body. It could be a body part. So you have two liquid plasmas in different ratios. Let's say, for example, 1:2 ratio. And then what is in the middle is balanced. So because this plasma gives to that, and then takes what the other one does not need. So there is a balance, so to speak, so that anything between those two is equal strength. And then if this were a virus, for example, that would mean there is no virus, because this plasma, the stronger one, has given to the weaker one, therefore creating a balance. So now, if you separate them, for example, when you them in the evening after use, if you separate them, so they are kept in a separate place. Let's say a bed, it could be here, your bed, so you keep them on either side. Then, and if they have some Gans materials, a little bit of Gans materials, which is necessary because when you bring liquid plasma, in any case, it carries bits, tiny bits of the Gans themselves, even though you won't see them. That is safer because now they are no longer giving to each other. They could be giving, but at quite a distance. But let's say you place them one on top of another. This, to me, would mean that they are equal now. They become equal. So that when you try to use them in this case, they will not be as effective. So that's why it makes sense, from my perspective, to renew the pads over time. Not that the Gans became weaker, but the use, the way you use it, would be weaker because they have already influenced themselves, they have interacted until now they are of equal strength. So the ratio of 1:2 disappears. That's the way I can best explain this. And I have heard that question many times.
Dr. Gatwa?
Yes, Jalal.
Do you allow me to explain it in simple way?
Sure,
please?
Sure.
Can you take a little bit from your drawing?
I can remove everything.
No, it's the left one. Have a little quarter of it, please.
Has a little bit of what?
From your drawing, only give me small space.
Use a different color because I don't know how to do this.
Okay, I will do that.
Let me see. Let me see what I can do.
I will do it, no problem.
Here. Is that enough?
It will show now. Just 1
Is
second.
that enough space?
There is nothing here. It's okay. Yeah, it's coming out. Okay, thank you, Dr. Gatwa.
Sure.
We need to understand plasma. Plasma is very simple. It is from atom, small one, to a man, to solar system, to universe. All one simple system is working with. Plasma is like this. Dynamic. It takes and gives. What's coming inside? Why do you see it or okay? Let's say what's coming from energy is 1. Always in the plasma condition must be 1 plus. That means what's coming in, it must coming out 1 plus. If it's a 2, it will go out 2 plus. That is the condition, the plasma. And that's great to everything you see and you feel. If it's a man, if it's a solar system, if it's universe. When this one become what's coming in 1, what's coming out is 1, that means this situation or plasma is ended. It need to regenerate. When it's coming in 1 and coming out 0, 9, that means this plasma must be vanished. Vanished, that means it's going back to the origin or going to another state of plasma. It's just like this. It's so easy to understand. This is plasma, whatever it is, a man, solar system, or universe. What's coming in, like a man, it must come out plus. Whatever it is, how much energy come in must come out plus. When it is the same condition, what's coming in, what's coming out, that means this condition is, there is no interaction in that situation. That means this man is died because there is no interaction between what is coming in and what is coming out. So that's easy. If you apply it to batches, if you apply it to reactors, if you apply it for everything, when you see there is no more interaction, there is no difference ratio between them, there is no interaction more, you need to bring back the elements to the origin to give it more power, or you can take it again from the source. Thank you.
Thank you very much, Jalal. We might also add that when you separate them, let's say the parts, when they are in separate places, stored in separate places, they continuously receive energy from the environment. That's the nature of Gans. And they also give to the environment. In that case, they would self-restore.
Yes, because there will be interaction, whatever you do. If you bring it back to the source, or you separate them, or you join them. If you see there is interaction between them, that means there is life in this part, in this core, in this anything. But if you see there is no interaction between them, you need to bring them back to the source.
So would you explain one case where you know of no interaction? I'm trying to think, and I can't come up with a good example. I think I don't have any example. There is
Okay,
always interaction.
okay. You have here a plasma. Let's say power of 1. If there is interaction with another plasma, smaller plasma here, that in this case, this interaction between them, whatever interaction is there, this source will be awakened because you have here 5 interaction with the source. So if this small one, how much it is? 1 or 0.5 or 0.4. This is the interaction between 2, 1 and 3. This is the source, and this is the weaker. When there is interaction between them, if it is dynamic, that means this one will always, the source will give to the weaker. But there is a time when this weaker, because there is no another interaction, only with these 2, this is, both of them will be in, I don't know the word, but this one will be 1.5 and this one will be 1.5. So there is no any more interaction between them. So you need to add another plasma to make reaction between them, or you bring the source back to the origin from where you took your plasma, let's say from the batch. You just add more from the source, or you bring it back to the source and you bring it to the batch again. You need to energize your batches or your whatever it is you are using in the plasma, because with the time, if there is no interaction, there is no adding to it, because you are only giving, that will not happen, because you will dissolve, because you need to take. So from where you are taking, you are helping. Let's say you are the source, and you are giving to the weakest, whatever it is. Without you are taking, you cannot feed all the time. So if you have a source to feed from, then you can give. But this source, what you are giving, it's very small. It's pulling from you all the time. And this will not happen. It will add to you. But in a way, if we say, in which way? In a matter state, or in the emotion state, or in the soul state, you need to have also that when you give, you need to take, that you give more.
Thank you very much, Jalal. And in every
Welcome.
giving, there is a taking. There is no one without the other. But given a particular condition where the giving is more than the taking, one might see the case that you just explained, and therefore need to re-energize. But it's the condition. If you separate them again, that will create a different condition, and they have really not lost in strength over time. It's just the way they interact. The way they interact better if in a different condition.
Yeah, but Doctor.
Every time one takes, one gives, they also get more than they actually gave.
Yes,
Yes.
but Dr. Gatwa, we don't have this perfect condition. We are speaking about perfect condition. But
Sure.
yeah, but now when you are separating,
I'm only supporting what you said.
yes, you say I know what saying.
Adding to it, yes.
Yes, thank you.
You're welcome. So if you are doing this like in a manufacturing processes where you may have a closed tank where the interaction happens, then you would want to, that would, the condition would be almost always the same. So that would create need for re-energizing of your guns, for example. That's the way I see it now. That's the way I understand it. So it's not really a weakening of guns. Remember, we cannot even get rid of the guns we create, we collect from the environment. When we collect CO2 guns, it's independent of temperature and pressure. You cannot overheat it until it disappears, or overcool it until it disappears. So it will always stay in the state of guns. I hope that answers the question. Any other comments or questions about guns? They happen to be very interesting.
Yes, Florian had some questions about reading, or I should say, measuring the plasma fields.
Okay, so what's the question?
Are you there, Florian?
Yeah, I'm there. Yeah, so I trained myself, my body with my soul in my body to be one, to measure these those plasmatic fields, and a lot of people can do it over the world, around the world, and yeah, if we can measure plasma with tools, it's better in a way that everyone can access to it. But if we use our body, we just have to train ourselves to be aware of this of those fields.
Okay, so what do you do with your body in order to measure guns?
So when I some people can see with the third eye, can see plasmatic fields and differences between those fields, and some experiment hotspots on their body. Some other I'm not that good in English for specific words, so I would use a translation. So some feels tingle, tingle when there is some plasma field. And me, I feel like a magnetic repulsion when there is some fields. When I make myself aware of those those fields, and I can with my hand sense magnetic repulsion with my right hand for giving or anything I want, and the other hand to measure my body fields, and with my right hand I can show a direction, like a way where there is a field, and with the other hand I can measure those fields by with actually this magnetic repulsion. I mean, my hand is moving away from my body when it's on a field, on a certain field, because we have a lot of fields in our body. And when I want to measure it, there is a lot of different jargon to explain and measure correctly those fields. I can exchange. I can actually. I'm trying to feed myself with pure prana energy, and this is kind of painful when there is some things to get out from my body, to be aware of this and to be present and to be I don't know, to be to use this energy to feed myself and use other energy of my body and to connect them together. And so I learned that like 2 years ago. I didn't stay in this state because it's kind of difficult when you see everybody eating foods, good foods, and you're like, it's for social experimentation. It's kind of hard to explain that you don't eat physical matter when it is already physical, but this is not a matter that we can see and we can interact with our hand. I mean, by seeing it. Yeah, I don't know. Do you have some question or something? I don't know how to say, how to tell that, or how to, yeah.
No question at this point, but thank you very much for your explanation. And to cut a long story short, what he just explains shows that we actually don't have a meter to measure right now the strength in terms of gravitational magnetic fields of one Gans versus another. But it's easy to know the direction of your rotation. If, for example, you are rotating cores, you could actually feel it.
Yes.
But we don't have the meters right now. And this is a new product. So we should come up with ways of measuring field strength, and that will be in the future. We will be able to do that. Exactly. Thank you very much indeed.
Thank you.
Sure. Any other questions or comments?
Yes, Mark Carlton had his hand up there.
Yeah, I just have some noise in the background. Let me see if I can, just a minute. I thought it was very interesting in 2015, Mr. Keshe said that milk was a Gans of the cow, or maybe it was a Gans of the Gans. So I thought that was very interesting.
What's that again? What was the Gans of a...
The milk from the cow,
yes, milk,
is in a Gans state, or it's a Gans of a Gans. I thought he said, and correct me, anyone, interact, because it's made with the energies of the cow.
Yeah, okay. Okay, it's made with energies of the...
From the cow.
Okay, okay.
The cow produced it's in a Gans state. Huh?
Sure. And not only that, let me explain here that even when you eat your food, the moment the food gets to your mouth, it becomes Gans, in Gans state. Our bodies are in Gans state. So yes, Gans, you can actually strengthen Gans in terms of field strength by creating GANs of GANSes. That is to say, you could have a product of your CO2 collection of CO2 GANs. So you have the CO2 in one container, CO2, you collect CO2 GANs in one container, and then collect a CO2 again in another container. So you have 1 and 2 CO2 GANs. They are not going to be of equal strength. It's actually impossible to create them in equal. So they are not equal as such, but there could be interaction. So if you wanted to make a stronger GANs of the two, you can combine the two. There is a process which I can just briefly explain. And then what you create, the GANs that will come from GANs, two of them, like a GANs of GANs made as a product of GANSes, in this case CO2, it could be zinc, would be stronger in terms of gravitational magnetic field by orders of magnitude. So there is a process of connecting this, using it as one of the plates, and connecting this, using it as the second plate. So the GANs become the plates, like copper, nano-coated, or zinc plate. So there is a process which I'm not going to explain here. It's outside these definitions. But a product of two GANSes would create a GANs of CO2 or some other GANs, but of higher order in terms of field strength. So what that gentleman just said is milk is in GANS state, and so is water. So it's a plasma state. We should say plasma instead of GANs. But once you go into the system, like if you eat your food, it gets into your system, right from the mouth, it becomes in GANS state. I hope that explains the question.
I thought GANS, I thought GANS was a step below plasma. Huh?
Below plasma?
GANS is a step below plasma, I thought Mr. Keshe said.
GANs are plasmatic themselves.
Okay. And just one other little comment about the stronger giving to the weaker. It's trying to hold on to the weaker, and it's trying to elevate the weaker to become as itself. Yes?
That's correct.
It's trying to put the weaker into balance.
Exactly.
But please don't forget one thing, the soul of emotion. Whatever you see in the plasma, in this science, there is emotion, there is soul of emotion. It's whatever you do. So even the milk, what you drink, it came from the soul of emotion of the cow.
Are you saying if the cow were very angry, it would, instead of producing milk, produce another substance?
Yes, absolutely yes. Even your ganses, what you are doing in the CO2 kit, if your emotion it's not to serve, you will have different kinds of ganses, because your emotion is the dictator, is the controller, is the whatever you call it. You are dealing with matter here, but your emotion is the energy source for this CO2 kit.
Thank you very much. Your point is well taken, but the cow will produce milk, maybe less milk, and when it's very happy, maybe more milk, or stronger in field strength. Thank you. Emotion is important. I have no question. No, I do not disagree. Any other comments or questions? If not, we'll continue with the GANS. Is interesting. I thought that was a very good discussion from one item, GANS. I have an example here, explanation from Ingrid. Ingrid used to teach these classes. And this is from one of her slides, just explaining further the structure of Gans. And she goes, here it's quote unquote, which becomes nano of itself. You know, we just read the definition of Gans. And she says with this expression, quote unquote, becomes nano of itself, Mr. Keshe refers to the circumstance that such molecules take on an inner structure which enables them to stay independent and do not further participate in chemical reactions, and gives them a lot of other new properties. What are those new properties? Such single molecules, or at least small clusters of molecules, build very tiny entities in the nanometer range. Remember, nano is defined as 1 billionth of a meter. So therefore, Mr. Keshe used the shortage nano to refer to this magnitude of entities. These are the entities that now have new properties. They can move from, they are dynamic, in other words. And now they become nano, solid, you can see them, nano, independence, and dynamic. So that's just an additional explanation that I thought was important. And now we move to the second three of the listed plasma terms. And this is very interesting. This part is very interesting. So you are in your own words. Please define the following terms: inertia, gravity, and nano. Please feel free to unmute and respond. This is very interesting, especially inertia and gravity and the difference. Anyone can start. There is no order of responses. Where is Jalal when we need him?
Yeah, don't all speak at once here.
Yeah, which means
At work. You hear that?
Okay. Yeah, where is Jalal when we need him?
Let me get my headphones on here, but I would like to just note the definition in the dictionary of the word inertia, which is a noun that says a tendency to do nothing or to remain unchanged. So in that sense, we are all under our own inertia here in responding to defining the word inertia, you might say.
And hence the silence.
It's a perfect example of the word inertia, actually.
Yeah. Yep. That's great, right?
Thank you very much.
Thank you, everybody, for your explanation of the word inertia.
By your silence.
Perfect explanation. But we need a change of inertia.
Yep, synonyms are inactivity or inaction, inertness.
Yes, actually, you know, that reminds me, the dictionary term reminds me of what Keshe says about when we know an atom physics, for example, and how they interact, then you go to chemistry, you mix them, and biology, when they begin to have consciousness or life. But what was missing in that explanation was where did the atom come from in the first place? And in this case, the inertia, the way it's defined in the dictionary, brings that point home, because yes, they explain the condition, but what creates that inertia is not part of the explanation in the dictionary. I thought that was interesting.
Yeah, yes, in physics, the definition is more, they call it a property of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force. So it's a tendency of objects to either keep moving in a straight line at a constant speed or to stay in a state of rest.
Thank you very much for that dictionary explanation or definition. I'm pretty sure that Mr. Keshe has a different explanation or definition, which we will look into.
Yes, exactly.
Yeah. Now, having expressed the definition of inertia by your silence, for example, could you express the same or define gravity by activity? Gravity couldn't mean the same as inertia. And what is the difference between inertia and gravity? Clint, are you looking at the Q&A or comments page?
Yeah, it's been pretty quiet here.
Yeah, 35.
It's Mark.
Yes, Mark.
Thought Mr. Keshe said it's similar, something like a soccer game. The guy is just standing there on the field or whatever, and then when the ball lands in front of him, he goes into action and does whatever he's supposed to do, and then when the ball's gone or he kicks it or whatever, he's back there standing again. Did that make sense?
Could you please elaborate even further?
Well, that's what life is, he said. Like a soccer field, like a soccer game. The guy's just standing there. But when the ball lands in front of him, all of a sudden he has to go into action. So maybe it's like with the plasmas as well. When they get close to each other, all of a sudden the interaction starts.
Thank you very much. Does that now explain inertia or gravity?
No, I have mud in the eyes on the inertia and gravity. The nano, I know, is small. You just said a billionth of a meter, yeah?
Billionth of a meter, but in respect to plasma science, it's also the other properties that that the material gets, which is individuality, especially. Mr. Keshe explained, emphasizes individuality of those atoms.
So when Rick,
to hear you now in your microphone.
No.
Yeah, you got to. You sound like you're a million miles away.
Oh, it's because I guess he's very strong. He's very strong.
But what Rick said, as far as not being in motion until enacted on, so that inertia idea, as the ball comes near the player, then he goes into motion.
Okay, thank you very much. Any other perspective? How about gravity? Gravity. Or shall we go to book definitions?
We can say two love each other.
Yes, can you hear me? This is Ed.
Yes, we can hear you, Ed. Go ahead.
Okay. I don't have any answers for what these things are. I mean, I have understood them in the past from science background and so forth and so on. But when Mr. Keshe uses them, it has always piqued my interest because I know I don't quite understand what he's talking about. He seems to refer to inertia when he's talking about physical gravity fields, like the Earth gravitational field. And he seems to refer to plasmatic gravitational fields as on a different level, as plasmatic. So my attempts to understand this is that inertia is on a certain like physical level because of the interaction of the physical bodies create fields of attraction, and the plasmatic fields are of a different nature or order or something. And I'm trying really hard to understand this because I think it's important. And so I was wondering if we could discuss it from that point of view.
We will discuss it from that point of view, and thank you very much. Your understanding is correct, but we will elaborate further, given what Mr. Keshe explains it.
Scott, something happened with your microphone. We can barely hear you.
Oh, I don't know what happened. Let me see.
Check your connection. Maybe it's not connected.
Or might have to adjust your audio microphone tolerance settings there in Zoom.
I just put my microphone on and I unmuted, and you guys weren't hearing me, and I was interrupting you, and then I just shut my microphone, my headset off, and now I'm back on just speaking, and it's working.
Mm-hmm.
Maybe having problems with low resources. I don't know, but let me try.
You have to go to your Zoom settings.
How do I do that from here?
On your main panel there, with your the orange and blue buttons, you click on settings, and then under audio, you want to go adjust the microphone settings there to raise your microphone levels.
I have to stop sharing in that case. Let me do that.
Mm-hmm.
See what happens. I'll stop sharing now.
And check and see if your normal microphone is there as an option to use as well.
Yeah, well, let me see what I can do. So you are saying go to video share and
no, it's
yeah, you can go to video share and the audio options show up.
Video
not video share, but video settings.
When I go to video settings, I see my face.
Click on the link on the left that says audio above it.
Yep.
Oh, okay. I didn't share my face, did I?
No.
No.
Oh.
And
you look beautiful, no problem.
Oh, I mean the audio, it's very low.
Yeah, so turn off automatic and drag that slider up about 3/4 the way.
Yeah, now I'm too loud.
We hear some background noise now.
Okay.
Okay, now turn auto on.
Or turn it on again.
Yeah.
Okay. How about that?
I think you sound okay.
It's a bit too loud now because it's amplified.
No, I think it's. No, talk again, Mike. Talk again there, Gato.
Oh, I'm too loud?
No, you're good.
I'm good. Okay, actually it's self-adjusted again, so if it's good, it's good.
Yeah, we can hear you good now without the background noise, yeah.
Oh, perfect. Okay, that's very good. Thank you very much. I learn something new each time.
we need little tutorials like that once in a while, Rick and Flint, about these mechanisms, how to do this or that or correct this and that, maybe a minute here and there.
Yeah, Zoom is kind of finicky.
Yes, but I'm glad you can now hear me. So, any other perspectives, or shall we just go to the book definition? Okay, we'll try that. We'll try that. we'll get rid of the inertia. I find this to be the best explanation of gravity and the difference between gravity and inertia. This is in book 1. I took these figures from book 1. Figure 41 and 42, where gravity is defined as simply, quote unquote, the total plasmatic magnetic fields, magravs, created by all components of the capital M matters, that is to say, matter, antimatter, and dark matter of the plasma, as shown in figure 41, link D and G, and figure 42, link G. Whereas inertia, through the new understanding of the structure of the plasma, inertia can be simply defined as, quote unquote, the plasmatic magnetic fields and gravitational fields due to the capital M matter in the small m matter, that is to say solid, liquid, and gas components of the plasma. Let me annotate to make that long paragraph easy to understand. So if you can see what I'm drawing here, we go back to the three components, the three main components of any plasma, or of fundamental matters, where you have principal matter, transition matter, in terms of magnetic fields, and matter itself, capital M matter, the fields that could actually create the small m matter, and that's what is explained here, the solid, liquid, and Gans. So what is explained here as the difference between gravity and inertia, in my understanding, is that inertia is a product of gravitational magnetic field from this part, only that part. While gravity, that's inertia. Inertia is a product of that part of the plasma, while gravity is a product of the total magnetic fields from the principal, transition, and matter. That may sound confusing, but it's really not, because from this part, we get it's the matter in this case, in gravitational magnetic fields, strong fields of strength. The fields are of higher strength. This part of the matter creates this. The matter, small m matter, is created of what we see as solid, liquid, or gases, comes from that component of the major plasma. Okay? We say it in each plasma, even when you make any matter or any ray, it goes with the seed of principle, transition, and matter. And the seeds may not necessarily become the matter you see, but from this part of that seed, you get matter that you touch, you see, you smell, that kind of thing. So that's what forms the matter magnetic fields, gravitational magnetic fields. From that part only forms inertia. Is that understood easily? Is that easy to understand? I will read again. Gravity is simply defined as, quote unquote, total, the whole plasma, total plasmatic magnetic fields, magravs, created by all components of the matters, that is to say matter, antimatter, and dark matter of the plasma, while inertia, through the new understanding of the structure of the plasma, inertia can be simply defined as, quote unquote, the plasmatic magnetic fields and gravitational fields due to the matter, capital M, in the small m matter, solid, liquid, and gases components of the plasma. I'll also read the captions because especially the one on the right explains that difference, why you have magraphs within plasmatic magnetic fields. But I'll start from the left one. Figure 41, interaction and connection between inertia of matter magnetic fields, of matter capital M plasmatic magnetic field, or PMTs, of an entity I and J in respect to another entity and the interactions F and H with magnetic field C and gravitational field D of systems respectively. But the number 42, figure 2, caption, the 40 to the right has a better way of explaining why you have magraphs within plasmatic magnetic fields of the components, the major component of a plasma. And I now read, note, in fact, the term used as quote unquote gravity has to be explained as gravitational and magnetic field forces, as when an object is attracted by gravitational fields of a matter, like the Earth. At the same time, it is repelled by the magnetic field forces of the object too. Thus, when talking about gravity, it is correct to note or to talk about the overall magnetic and gravitational fields, magraphs. It's clear as mud or as clear as crystal?
May I make a comment?
Sure.
This is quite helpful. And so I'm still thinking in terms of that what we used to term as gravity, like the gravity of the Earth, is actually gravity on a physical component state. And Mr. Keshe refers to it as inertia. I've been aware for some time that the gravitational fields of the Earth, in the old terminology, what we would term as the Earth gravity, everybody seems to think that it just pulls everything towards it. But I've come to the realization that it only pulls things of like matter. And it's just it happens to be everything that we see, so we think it's pulling everything, but it's only pulling the physical matter state. There are things on a plasmatic level that are not being attracted by that, quote, physical state of gravity or inertia. Is that correct?
I think that you are talking about inertia now, which
yes,
is a product of the matter, the physical matter, the gravitational magnetic fields that actually create small m matter, which you would call physical in terms of solid, liquid, and gases. So here, what I see is a deeper explanation or definition of gravity, which now separates into inertia and gravity itself, but in other explanations, they would seem to be together because we are not considering their source, where they came from in the first place. So Mr. Keshe here makes it clear of the magnetic gravitational fields that actually make up inertia, as opposed to the gravitational magnetic fields that make up gravity. Is that clear?
I think so. So let me state it this way. So when the Earth core creates its physical boundary, what we think of as the Earth, the physical structure of the Earth, it becomes in the matter state, not the plasmatic state, but the matter state of the Earth. Then that matter state body of the Earth creates its own gravitational and magnetic fields, which we term as inertia, but it only applies to that matter state. Is that correct?
It creates both. There is both gravity and inertia.
But the gravity is from the plasmatic state or the total state.
The total, that's the key word. The total.
Okay. Yes.
But inertia is not from the total, it's only from the capital M matter component of a plasma.
When Mr. Keshe talks in the kids' workshops and he shows the magnets, and these magnets are made of iron, and he refers to them as examples of the plasmatic forces. The iron is attracted to the iron because of a certain gravitational magnetic attraction and repulsion, but it's only respective to the iron. We know that magnets can be created for other things like wood or plastic as well. I mean, I don't know how to do that, but I know plasmatically it's possible. They each have an attraction and a repulsion for each other, but only at a certain level.
Yes, let me try to explain. You see, if you could come up with the field strength of the field strength, that means to say gravitational magnetic field strength of wood, a piece of wood, for example, and you created a gas, whatever you created of equal strength, that means you could actually put your hand through the wood. In other words, if they are equal, you can put your hand through it, yeah? So a table, what you see as a table is not the physical table that you actually see. They are tiny bits of gravitational magnetic fields that are dynamic. And that's actually very important because now this brings the idea of spaceship. So spaceship is a matter of knowing the gravitational magnetic fields of the place you want to go, yeah? And then creating those fields strength so that you are attracted, just like the magnet. A ring magnet attracts another ring magnet, or not attract, but gives to it in terms of pushes it out. It could do both. Either attract it, and when it attracts it, that is gravity, gravitational. When it pushes it away from itself, that would be magnetical. In other words, it's giving energy to the smaller one, and the smaller one moves. And in this other case, it's taking from it, it's bringing it to itself. So unlike poles attract, like poles repel. In other words, that just explains the entry of any plasma or exit, entry and exit. So yes, Mr. Keshe says that we can create magnets for anything else. In fact, that's how we collect CO2 guns. CO2 guns, we just create a magnet that attracts carbon from the environment, brings it into our saltwater solution, where it is oxidized by the oxygen in water, and then it forms what we know as CO2 guns. So yes, you can create magnets of anything you want. In fact, magnets, what I have in mind was we attract using the magnet that we create for CO2, and we can go to space by creating magnetic fields of the moon, for example, or knowing how to do it, so that the moon attracts us, just like the magnets attract each other instantaneously without any time lost, zero time. And so does that make it clearer?
Yes. So Mr. Keshe has always taught that the interaction between two plasmas is because they are of near or equal strength level.
That's correct.
And so would it be correct to understand the difference between gravity and inertia as just different attraction or different strength levels, different levels of strength of gravity and repulsion, of attraction and repulsion?
That's part of it. That's part of it because the principle is very strong.
Yes.
Transition is relatively strong in respect to the matter here. This would be the weaker. And those weaker ones even become, when they become even weaker, they make the small m matter that is solid, liquid, or gas. In fact, the best example that you already know of is making soap. How is soap made? You create, soap is made with mixture of oils, yeah? Oils. How then does it remove oil from your hands when you have eaten oily foods? It's because you created similar or equal gravitational magnetic fields that actually washes off oils. Even though it's made of oil, and hence its similarity with its work. You make soap out of oil, which is nano-coated in caustic material, caustic, do you call it soda, caustic soda, or sodium hydroxide. We use the same to make soap. In order to remove oils, we use oils, which is similar in respect to it, to strength of the fields. So yes, the similarity here is in these matters, capital M matter. From that, you get the matter that is solid, liquid, and gas, or small matter. And then that's what creates inertia, but which means it's of relatively weaker gravitational magnetic field forces than the major components, all of them combined, that create gravity.
So inertia then, since it's composed of the matter, capital M, and the matter, small m, solid, liquid, and gases, then that's the things that it would attract. Inertia would attract matter, capital M, and matter, small m, but not the dark matter or the antimatter.
Remember, even within that plasma, whatever plasma comes from this part of the matter, the capital M matter, even though it's now the small matter with the small matter M, it also has, it carries the seed of the mother.
Okay.
The principle, the transition, and the matter. So yes, it manifests itself as small m matter, but that it does not mean it doesn't have the principle, the matter, and the transition. Just like us, we manifest ourselves as human body. So you may call yourself a body with a soul, but in actual fact, your soul is stronger than your whole totality of your whole physicality. So it would be better to see yourself as a soul with a body. Make sense?
Yes. You brought up this aspect of the soul and the body, which I was just contemplating also, this difference between gravity and inertia. I'm wondering if it's similar to the difference between the soul and the soul of physicality.
Yes, it's similar, but we won't go into that. But that's very good food for thought.
Yeah. Okay. So in understanding the difference between inertia, I know you're stressing that every component of the plasma has the seed of the totality within it. But in terms of understanding the difference between the terms inertia and gravity, is my thought process is on the right track of thinking of inertia as in the matter state of the matter component, and that's what it is attracting and repulsing?
Well, that is not necessarily not correct. You see what I mean? In terms of your understanding, you have to go back to the actual component of Na plasma. And this is the way I find it easy to understand, because you remember I also took a long time to get this wrapped around my mind. It's not so easily understood the first time. But, but
Okay.
once you are not alone, you are not alone, my friend. But
Okay.
once you go back, once you can go take yourself back to the original, remember this is the principle, this is the transition, this is the matter. But these are in very fundamental. These are the seeds. So they have, all of them are very high field. But if you just remember from that, the totality fields from the total would come up with that's where gravity comes from. And then you look at definition, defined simply as quote unquote the total plasmatic magnetic fields magraphs. These are magnetic fields from the total, and they are plasmatic magnetic fields themselves, yeah, from the total magraphs, magnetic fields. And then look at inertia. But now when you consider inertia, don't think of the total, just think of this part only, the one that has M only. That's what constitutes the inertia materials. Yeah?
Okay, thank you so much.
Easier. Because from this one, you get the small m matter, not from the principle. The soul will never become physical if you think in terms of the soul. But it has examples of its physicality in that each matter carries the seed of the soul. Yeah?
Yeah,
That's the way I see it.
thank you.
Oh, you're welcome. Any other questions or comments? I hope these terms are becoming, the more we discuss them, the more we get to know them, the easier
Thank you.
we understand them when they are written in the textbook. Because if you just read plasmatic magnetic fields and then magraphs and then capital M and small m, it can be quite a task. But once you know them, then no problem. And we are all learning. I'm learning with you too. So that taken care of, gravity and inertia. These are very important concepts to think about. And now we'll go to nano, which is really interesting. We talked of nano as 1 billionth of a meter. That is conventional science description of nanomaterial. But here in plasma science, we think of individuality of those entities in nanoscale. To the right, if you look at carbon dioxide molecule, what nano explanation of that would be, the two O's and the C are not necessarily a molecule. They are because of their affinity to each other. They tend to stay close together. But individuality means that the O could move to another molecule-like structure of the nanomaterial that is of equal or similar field strength. That means this molecule is not attached, like it's not glued together. The O can move and be accommodated somewhere else. The C can move and be accommodated somewhere else. And then another C will take its place. So they may form structures like molecules, but they are actually independent. Another very important point is that they are not only free to move, they are independent of temperature and pressure due to their individuality of atoms. So atoms make up a molecule. So you're looking at a carbon dioxide molecule to the right bottom, but each, like O itself, it's not a molecule, it's an atom. So nanomaterials are atomic. So let's think of a nano-coating copper.
Gato,
Yes.
this is interesting because this gives us a clear idea. Because can you remember? I forget who had made this experience of heating the GANs and freezing the GANs, and
That was me.
it was you,
Yeah.
and it didn't acquire temperature.
Yeah, a lot of us tried. I mean, and we still get the same. In fact, I saved it. I heated it. It was still, it retained its structure. I put it in the freezer. It retained its structure. It's been there for months and months. Half a year already.
Yeah, but somebody even touched it, and it doesn't acquire temperature at all.
Yes, somebody measured that. That was not me.
Yeah.
I think it was. I think it was Paul.
Yeah, exactly. Yes. And how is it? How is it you manage to heat it up? The GANs or the CO2 in the water, or in the powder state?
I heat it in water. In water, I boiled it.
But then the
And
water would boil.
And then when it cooled, I could still see the GANs.
Fine, but I mean, the water heats up or it freezes, doesn't it?
The water does, but the GANs themselves don't.
The GANs remains in the bottom.
Yeah, and they don't boil. If you can measure, they are free of temperature. They are independent and pressure. You heat it, they are still not heated. You cannot destroy the CO2 GANs that we collect, whatever you did, in any way or form. Yeah, it's very interesting. This explains the nano quality. So let's see.
And what about, because we're recommended not to touch it, but for some medical uses, they're applied on different what do you call it? Problems you got on your skin, and they cure it.
Well, yes, I am not from the health department, but of course, we follow the instructions. Don't touch it. But we are also not. We are also the GANs, as you said. You just said we are not supposed to touch. Like, are you talking about the nano layers in a copper, for example?
No, the GANs.
But John, you make a lot of liquid plasma which you give to people. They use it for their hair or their eyes.
Yeah,
Yeah. So even though they are not touching it deliberately, it's in the liquid. There are some small parts of it.
Yeah, but I don't know if you've heard one of the first classes or the first couple of months I was in the class.
I know.
Yeah. I drank some of the GANs. And
John, this is excuse me. This is a public workshop, so we can't talk about the health aspects like that of the GANs. This is not okay for the Keshe Foundation. We're we're liable for such things if we're teaching this in this class.
Thank you, Rick.
Yes.
Sorry.
Yes, thank you. Thank you very much, Rick. So yes, we follow the instructions as Mr. Keshe gives them to us. If he says don't touch, and no, completely no, that you cannot ingest Gans material. What you do is you use the water above the Gans. That's why we talk about liquid plasma. So yes, this is a nano actually is a very good explanation of why the qualities, the extra qualities that this atomic structure now acquires is not only atomic and in nanoscale, which means 1 billionth of a meter in scale, but it has acquired new properties of independence and independence from temperature and pressure. And of course, independence to be dynamic, to move. So what happens when you nano-coat a copper material? The copper atoms now may find position here. One that was here may find position here. But if there are already others, what happens? They kind of move to accommodate the new one. Then another one pops from here and wants to stay here. What do the others do? Because they are already formed. They don't complain. They say, you are welcome. Then they move a little bit to adjust. And that's what is called as MAGRAV positioning, magnetic gravitational fields positioning. MAGRAV, that is the same thing, that is the same power or energy that keeps the sun and the moon from falling. We look at the moon, it's suspended in space. Look at the sun, it's the same. Look at stars, same. When you go to the moon or planet Zeus, you look at the earth because you land on this side. So the earth will appear to be on top of your head and it will be suspended on air, but it's not falling to the moon. So what keeps them in their positions relative to each other is magnetic gravitational fields positioning. Just as what is happening with these nanomaterials in atomic structure now that has popped from the actual copper, and they are held in position above the piece of wire by the magravs. They are dynamic, they can move.
I have a question regarding this.
Okay, go ahead, please.
I've thought of this often in terms of the nano-coating as I've come to understand it better and better, but this ability to move and acquire their independent MAGRAV positioning with each other, does it change when you dry your nano-coated copper? When you go through the drying process, do they become less able to move? When they're being formed, they take a certain position, which allows them to conduct plasma very well. When you dry it, does that, quote, solidify and become just one state then, not able to change as easily?
No. Actually, it's the reverse. It becomes even better because every plasma, let's see, every plasma again has an entry and an exit, yeah? The entry is what you refer to as the magnetic, gravitational. You see how they used to teach us about magnets? You would see that there is an entry there, which they call South Pole, yeah? And there is an exit there, which we call North Pole, yeah? So this North Pole, if you think of it as, you should think of it as exit of a plasma. But because we don't have flat plasmas or rectangle plasmas, they are all, except those that we make to show, which are very confusing. In the universe, we don't have those. We have, in fact, spherical plasmas and magnets, okay? So this is the gravitational fields where they enter. This is the exit. What you do with the nanometer, what do you call it? A multimeter. And this is through the layering process. The second process of nano-coating is that you polarize these materials so that they have an exit and an entry. See now what that does, because they're polarized. The face one, or the exit is one side, and the entry is one side. In other words, you could say that this is gravitational, and this is magnetical. What that does to the layers themselves of the atoms is create a superhighway where you can store energy and information. Because why does it become superhighway? They are all facing one way or another. There is an exit and there is an entry. When there is an exit and entry, it's easier to move. Yes? And
Exactly.
when you know the exit or the entry, you go back and forth, back and forth. But here you are going straight. If it's entry, you just enter and go straight. So superhighway. Okay, let's see what happens. And this is in 3-dimensional. They are not layers like flat.
Yes.
What happens when they are arranged like this and they accommodate themselves? Between these materials, the atomic layers of the copper, you create 3-dimensional envelopes. You see these envelopes between them?
Uh-huh.
That becomes the super place. That's the superconductor of whatever you want to keep. You place it here. There is a space to hold extra information or energy. You see, there is actually on the Keshe Foundation website where you see nano layering explained, nano coating, including nano layering. This also is explained as super envelopes that are in 3-dimensional, 3 dimensions that actually are very good for the information that you want to store. These are super envelopes. So you not only have the atomic atoms of copper facing, layered and polarized, you have created a superhighway and a lot of storage for extra information and energy. That's why they become very good conductors. In fact, they are superconductors. So layering does not compact them. It polarizes them.
Yes, and that structuring is done during the drying period.
That's correct. That's where you use the voltmeter.
Yes, but once it is dried, once it is already dry,
yes, you don't compact it.
It stays fixed as the way it is.
Yes, it stays like that. That's why we don't touch it. That's why you are advised not to touch that material, because remember they have tiny layers between 20,000 and 50,000 on top of the wire. So if you touch it, you break them, you compact them. That's why we stay away from compacting.
So when we dry it, the independent or the moving aspects of the nanomaterial then becomes not so movable.
No, it doesn't, because you don't compress it, it stays movable, very flexible.
Well, the plasma can move in between the nanoparticles because of its structure, but the nanoparticles themselves, aren't they less free to move once it's dry?
Not less free. What they are held in position already. They are already in position, yeah? They are already in position due to Margraaf positioning, yeah?
Yeah.
Margraaf positioning. But what happens if a new one comes from the wire and pops here? Here, for example. They are not compact in that they have to accommodate the new one. They move.
Even if it's dry?
Yes.
Okay.
Layering, but layering will not occur when you have washed the caustic. But supposing something happened and there was increased energy field so that this became stronger than the friend that is staying next to, and it wanted to go here because it thought that this one was of equal strength or similar strength to it. I believe it moves there. I may be wrong. Yeah.
Got you. I've got that video if you wanted to have a look at it. It's about 3 minutes long. Nano particle, nano layer video kind of explains everything that we're talking about here.
Rick,
I've got another short video that I can show of interaction of particles, you might say, with a different kind of magnetism. Go ahead.
Yeah. Sure. Go ahead, please.
I could give an idea. If we get hold of a galaxy in space and dip it into water, it wouldn't change its independence of all the suns and Earth round in the galaxy. We just immerse it in water, and then we'd take the water out, and it would retain the same shape.
Okay, John, we're going to have a look at this video here first, and maybe that'll answer the question for people in a way that makes sense for them. Let me just get that set up properly here.
Perfect, Rick. This is really nice.
Okay, do optimize. Okay, there's no sound in this one. It's just a, I believe that's true. It just shows the actual process. So let's have a look at it. We can talk about it as it's playing, perhaps, if you want. Okay, I think this should do it. Okay.
No, just play it because it's self-evident, which it will show. We don't have to talk about it.
hey, Rick, could you stop it here for a moment?
Okay.
Actually, I tried to say that, but my mic was muted. It was back a couple of frames where it talked about the the physical matter state is dependent on temperature and pressure. The monoatomic nanolayers position themselves and are connected through gravitational magnetical fields. I just had a flash of a thought wondering if that is somehow related to our what we just finished talking about previous, the difference between inertia and gravity, if they're being held by different forces.
No, the difference between gravity and inertia is the mother of gravity and the mother of inertia, which is different. The mother of gravity is the total plasmatic
Well,
materials.
well, I know it's not exactly the same, but I was just wondering if I mean, there's different field strengths that are holding the physical matter together and the monoatomic nanolayers together.
Sure.
Rick?
It was just a thought. I just wanted to pass that by somebody.
Rick, the optimization doesn't let us read anything.
Oh. Okay, let me try to reset it or something here.
Some of us can read everything, so I don't know why he can't. I read through everything.
You could read everything? I'll try.
Well, I mean, and depending on your local internet connection, it could have been reduced to pretty pixelated, yeah.
Should I leave optimize on or off?
Oh, well, for this one, since it's just static slides or something, yeah, we could just leave it off for now. That should fix it for everybody, though.
Yes, and we are about to finish it anyway.
Yeah, and we're also about 10 minutes over here, so.
Right, so I just wanted to finish it up here, and it's only another few seconds. So that's basically it, and people can review the videos if on the recording if they wish to have a better look at that. It's got a lot of information in it. Actually, it might be good to have a look at again, and it's available in a different form on the website or on the YouTube channel as well.
Thank you very much. Thank you very much, Rick, for showing that, sharing that. Excellent.
I did have another quick 1-minute video if we had time for it. I know we're 10 minutes over, but it shows the interaction of particles and different forces than gravity and the idea of a magnet that's not iron.
No, just, yeah, please share.
All right, so let me quickly do this one. It's one of my experiments that I was doing recently, and let me get it set up here. Okay. I think I'm supposed to optimize this one. I'm share the sound. Okay. There we go. Okay, so what you see is a couple of particles, you might say. They could be perhaps nanoparticles, or they could be Gans particles. Depends how you look at it. And I'll show the interaction of fields. And sometimes you might want to look in what's in between the particles here. Okay, here we go. There, wasn't that fun?
That's pretty cool, Rick.
Excellent. Thank you very much, Rick, for sharing.
Excellent.
So I have one related question. So let's assume let's consider that maybe these two little balls, silver balls, are Ganses. When they're in the liquid state, is there any difference to their freedom of movement and interaction with one another than if the Gans is dried and in a powder form?
Yeah,
Well,
to me, dried in a powder form be like putting concrete inside this.
So their independence then would be put into more of a solid structure, and it would not change.
Well, look at what you see when you look at the CO2 Gans, and it's this beautiful liquidy, it's like smoke inside of the liquid of the container. It's so fine, it's so beautiful in its interaction, and so independent, so free.
Right.
You take away all that plasma liquid, all that stuff in between the particles, and they lose all their elbow room. They're all stuck together, they're jammed together, and they have no freedom. Well, they're still free. They're still free, independent particles, but they're not in an environment where they can easily express their individuality, you could say.
Their movement is limited.
Yes, that's what I think. And then if you put that back in water, it doesn't necessarily rejuvenate their movement, because then they're stuck together with their friends, and they've lost their elbow room, and they might have lost some of their life as well. Anyway, we do have to wrap things up here. It's an interesting question. Maybe we should carry it on to the next workshop or something.
Yes, thank you very much, Rick. So we managed to cover 6 of the 9 that we set out to do. So next time we will continue with other definitions. We still have not looked at field interaction, what was just shown, and the way it's defined by Mr. Keshe, and then the neutron, the initial plasma, and how neutron decays. So we'll do that next time. For today, thank you very much for your lively discussion. I wanted to create a discussion, and we started slowly, but we picked up somehow, and it was excellent. So I very much appreciate all your input. That's what makes our learning better and better each time. So for now, that brings to an end my presentation, and I give it back to Flint to bring this session to a close. Over to you, Flint.
Thank you, Dr. Gatua.
You're welcome. Thank you.
Yes, thank you so much, Dr. Gatua, for another wonderful session today.
You're welcome, Flint. Thank you.
And thank you everyone for joining today. This has been the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, March 19th, 2018. It's Dr. Gatua Wambogwa, Exploring Plasma Science, Part 6. We'll continue next week, same time, same place, for another episode of the Exploring Plasma Science series. Be sure to join us tomorrow. It'd be 4 p.m. Central European Time for the 32nd One Nation, One Planet, One Race for World Peace public meeting. Until then, have a great rest of your day, afternoon, or evening, and we'll see you then.
Thank you, Dr. Mbugwa.
You're very welcome. Thank you.